All right, let's talk about EPLAN. It's this incredible tool that's a huge deal in modern electrical engineering. And hey, if you've ever thought that designing a professional electrical system is, well, just about drawing some circuits, you're going to want to stick around. We're about to see things in a whole new light. Okay, so let's get right into it. On the surface, making an electrical schematic sounds pretty simple, right? You just draw a few lines, pop in some symbols for motors, switches, whatever, and call it a day. But, and this is a big but, in the real world, we're talking industrial automation, complex machine building. That's barely scratching the surface. It's just the very beginning of the story. So yeah, why is it so much more complicated? Well, think about it. Every single line, every little symbol on that screen, it's not just a picture, it's a real thing. It represents an actual component with a specific part number, its own unique dimensions, and a whole web of connections. We're talking about managing literally thousands of these details, making sure every single piece complies with major safety standards like IEC or UL, and then you've got to spit out a mountain of reports for the manufacturing team. You can imagine trying to do all of that by hand. It's a complete recipe for disaster. And that right there is where we need a total shift in how we think about this stuff. The answer isn't just a slightly better drawing tool. No way. The solution is a whole different class of software, one that's built from the ground up around data. And that, my friends, brings us to the very heart of what EPLAN is all about. So here's the key definition. EPLAN is an engineering platform. That word is super important. The whole idea is that every single thing in your design, whether it's a huge motor, a tiny wire, or a single terminal block, it isn't just a drawing. It's an object stored in a central project database. It's no wonder this is the go-to tool in big industries like industrial automation and machine building, places where you absolutely cannot afford to get it wrong. Complexity and accuracy are everything. Let's just hammer this point home, because it's the whole ballgame. We're talking about a move away from just, drawing shapes with a typical CAD tool. We're leaving that behind and stepping into an intelligent, rule-based system where the software actually understands the engineering behind what you're designing. It's like graduating from just drafting lines to actually engineering a system. It's a massive leap. I know. Talking about a database can sound a little dry, a bit abstract, right? So forget that for a second. Let's actually take a peek inside the software itself, because this is where the magic happens. This is where you can see what this whole data-driven thing really means in action. Okay, look at this. What you're seeing on your screen right now, that is not just a pretty 3D picture. It's what we call a digital twin of a real-world control cabinet. Every single component in there, the PLC, all those terminals, the power supplies, it's an intelligent object that is live linked directly back to that project database. What does that mean? It means if you change something in the schematic, boom, it changes right here in the 3D model, instantly. And it gets even cooler. This is where it just blows my mind. Because the system knows the exact size and location of everything, it can automatically figure out the absolute best path for every single wire. It's checking for collisions, like will this wire run into that component? It's calculating the exact length of wire you'll need. Basically, it's making sure everything is going to fit perfectly in the real world before anyone on the shop floor even thinks about cutting a wire. And this screen, this is basically the command center, the beating heart of the whole system. This is the live project data. So if an engineer anywhere on the team changes just one little component in the schematic, the device list, the 3D model, the bill of materials for purchasing, everything updates automatically in real time. The database becomes what we call the single source of truth. There's no more guessing which version is the right one. Okay, so we've seen some of these incredibly powerful features, but how does it all come together in a real project? Let's zoom out and look at the whole life cycle, right? From that first back-of-the-napkin idea all the way to the finished documents that go to manufacturing. You can see the workflow here is just so logical. It all starts at the beginning. You define the system, set your standards. Then you get into designing the schematics. And as you do, that central database starts filling up with intelligent data. After that, you're managing the actual real-world parts, laying out the physical cabinet, and then, this is the best part, with just a couple of clicks, EPLAN automatically generates all the documentation. We're talking bills of materials, wiring lists, everything the manufacturing team needs to build it right the first time. So, the big question is, why does any of this actually matter? What's the payoff for an engineer or a company? Well, the advantages are just massive. First, errors pretty much evaporate because the system is constantly cross-checking everything for you. The time savings are huge. Imagine not having to manually create reports ever again. It also has all the major industrial safety standards built right in, so you know you're compliant. And it can scale from one tiny control panel all the way up to an entire plant. Plus, it plays nicely with other business software like your ERP and PLC systems. Now, I know what some of you are probably thinking. Hey, my current CAD software has an electrical version. How is this any different? That's a great question, and honestly, understanding the answer is the most important takeaway here. It all comes down to the fundamental approach. Let's just put it side by side. Look at AutoCAD Electrical. At its core, it's geometry-based. It's about drawing really smart lines and symbols. EPLAN, on the other hand, is completely data-driven. Cross-references? In CAD, they're often semi-automatic. You might have to update them manually. In EPLAN, they are 100% automatic and always live. And then you get to things like 3D cabinet design and generating reports. Honestly, it's not even a fair fight. The difference is just night and day. It really boils down to this single, simple idea. AutoCAD draws lines. EPLAN manages engineering data. That's it. One is a highly advanced digital drafting board. The other is a complete data management platform designed for complex engineering projects. It's all about shifting your perspective from just drawing to truly managing information. And I really want to leave you with this one final thought, because it changes everything. EPLAN isn't about helping you draw schematics a little bit faster. That's not the point. The real point is to help you design electrical systems that can actually be built, wired, and maintained out there in the real world. A system that works from day one and for years to come. That, right there, is the massive difference between just drawing and truly engineering.